This is section 2-5. We're going to be looking at the distributive and equality properties today. So this is the section where we're going to apply logical reasoning to algebra and geometry. The concepts we're going to cover should be familiar concepts, but you may not have seen them explicitly described or written out for you before. These properties will help solve problems and help you justify each step that you take when you're solving a problem. So first, let's go ahead and take a look at properties of equality. Our first one is the addition property, and what that says is if A equals B, then A plus C equals B plus C. So really all this says is that if I have, let's say, A equals 2 and C equals 3, then if I say and A equals B, if I'm given these things, then I can say, well, A plus C is the same thing as 2 plus 3, and B plus C, C is 3, and over here A equals B, so that means B has to equal 2, so then B is 2, and so I'm looking at 2 plus 3 and 2 plus 3. Those are both 5. So these are, in fact, equal. That's all that property says. Next up, we have the subtraction property, which is really similar to the addition property, just with subtraction instead. So if A equals B, then A minus C equals B minus C. And so let's look at an example. If I have A equals 4 and C equals 1 and A equals B, and I set up the problem A minus C and B minus C, well, I know already that A is 4 and A equals B. So that means B equals 4, and then I have from my information that C is 1, C is 1, so that means that we come out with 3 and 3. So in fact, since these are equal, A minus C equals B minus C. Our next property is the multiplication property, and so this says if A equals B, then A times C equals B times C. So this is just saying if I have the same number and I multiply it by the same number, I get the same answer. So let's look at an example. Let's say we have A equals 2, A equals B, and C equals 3. And I want to evaluate the expressions A times C and B times C. Well, I know A equals 2, and I know A equals B, so B is also 2. And then C is equal to 3. Look at that on both sides. So 2 times 3 gives me 6, 2 times 3 gives me 6, and in fact we come out with A times C does equal B times C. The next property that we'll look at is the division property. It says if A equals B and C does not equal 0, then A divided by C equals B divided by C. The reason C can't be divided by, or can't be equal to 0 is because we can't divide a number by 0. So what this says, if I have the same number and I divide it by the same number, I'm going to get the same answer. So let's look at an example. Let's say A equals 9, C equals 3, and B is equal to A. So I'll set up my problem. A divided by C is going to be 9 divided by 3, and B divided by C is going to be, A is equal to B, so B is 9 and C is 3, so this gives me 3, this gives me 3, and so we find out that these are in fact equal. The next one we're going to look at is the reflexive property. All this one says is A equals A, so this just means that something is equal to itself. This seems silly, but it'll come in handy when we're proving a lot of conjectures with angles. The next one that we have is the symmetric property. This one also seems kind of silly, but it's another one that's going to come in handy when we start working on proofs. And all it says is that if A equals B, then B equals A. So basically it doesn't matter which side of the equal sign is on, these two expressions are the same. And the transitive property. So this is really similar to our law of syllogism that we looked at in our deductive reasoning section. So what this says, if A equals B and B equals C, then we know that A equals C. Let's take a look at an example of this. So what if I have A equals 20, and I'm told that A equals B, B equals C. Well, A is 20, so that means since A equals B, B is 20. And since B equals C, then C is 20. And, oh, it checks out. A is 20, C is 20, so A equals C. Our last property of equality is the substitution property, and it says if A equals B, then B can be can replace A in any expression. So that means if I have the expression 3 times A plus 6 and A equals B, then this is equivalent to me saying 3 times B plus 6. And these would be equivalent expressions. We're now going to look at the distributive property. You have probably seen this before in your algebra classes, and so this should be a quick review for most people. So, distributive property concerning sums, it says that if I have the expression A times the quantity B plus C, then that is the same thing as A times B plus A times C. My method for solving this, I like to call it the double rainbow. So A times B plus A times C. So if we look at an example, if we have A equals 3, B equals 2, and C equals 1, then I can set up my expression A times B plus C is going to be A is 3 times B, which is 2, plus C, which is 1. And so if I do this just using my arithmetic skills, 2 plus 1 here, that's going to give me 3. So 3 times 3, and then that gives me 9. Let's check out the distributive property. So if I use the distributive property instead and go 3 times 2 plus 3 times 1, so 3 times 2 plus 3 times 1, 3 times 2 gives me 6, 3 times 1 gives me 3, and then I have 6 plus 3 equals 9. It checks out. So these two statements are equivalent. Now we're going to look at this using differences. So if I have the expression A times the quantity B minus C, then that's going to be the same thing as A times B minus A times C. Let's look at an example using the distributive property with differences. So let's say I have A equals 2, B equals 10, and C equals 3. So then if I set up this problem, A times the quantity B minus C, I'm going to have 2 times 10 minus 3. And so using my arithmetic skills, do the parentheses first. 10 minus 3 is going to give me 7. 2 times 7 gives me 14. So then, let's try this using the distributive property. So if I go 2 times 10 minus 2 times 3, using my double rainbow, I have 2 times 10 minus 2 times 3. Well, that's going to give me 2 times 10 is 20, minus 2 times 3 is 6. 20 minus 6 does give me 14. This checks out. So these are equivalent expressions. For this video, there won't be any practice problems. We're going to use our new skills in class tomorrow, and we're going to work on some beginning proofs. It's going to be awesome.